Hello everyone, I hope you all are doing well. I am Tanushree and welcome back to my channel. In this video, we are going to talk about the basics of mass and energy balance, and we are going to solve some numericals on mass balance. So without making any further delay, let's start the video. So, mass and energy balance are required in many food processing operations such as evaporation, separation, drying, then we have extraction, heating, cooling, mixing, and etc. So, material balance or mass balance are based on the principle that matter can neither be created nor destroyed. Thus, in any process, a mass balance can be made as mass balance can be written as inflow is equal to outflow plus accumulation. Now, if the accumulation is 0, then it is a steady state. Okay. Now, we can say that inflow is equal to outflow. And if the accumulation is not 0, then it is an unsteady state. Fine. Now, basically during doing the mass balance, we need to make two equations. So, first one is total mass balance and the second one is the component mass balance. With the help of these two equations only, we can do the numericals of mass balance. Moving on to energy balance. So, in energy balance calculation also the same thing is followed, that the energy can nor be created nor destroyed. So, the amount of heat energy entering a system must be equal to the amount of heat energy leaving or getting accumulated. So, again it will be like heat in is equal to heat out plus accumulation. And the same thing repeats that if accumulation is 0, then it is a steady state, or the vice versa. That is, at a steady state, the accumulation will be 0. So now let us start with the question. The first question is, a moist food having 80% moisture and it is being dried to 60% moisture. The final weight of the product is 25 kg. Calculate the amount of moist food entered the dryer and the water removed. So, we can first draw the diagram. W kg of water is being removed, which has 100% moisture content, and this is the final product, which is 25 kg of weight having 60% moisture, and the feed we don't know how much, so let it be x kg, and it has 80% moisture. Okay, so let us start. At first we will do the total mass balance. That is, x is equal to w plus 25. Let it be equation number 1. So, it is justified that input is equal to output. Next we will do the component balance. We will do the component mass balance with respect to moisture, as we know the moisture content of the feed and the product. So, it will be 0.8x is equal to W into 1, as it has 100% moisture, plus 25 into 0.6. We can write it as 0.8. Let this equation be 2. We can put the value of x from equation 1, W plus 25 is equal to W plus 15. Okay. Next step is 0.8 into W plus 20 is equal to W plus 15. So we can simplify it as W is equal to 5 by 20. 5 by 0.2, which is equal to 25 kg. So, this is the amount of water removed. And now, we need to find out the total amount of food entered the dryer, that is the feed. So, from equation number 1, we can get this easily. X is equal to W plus 25. So, it will be W's value we know, that is 25, and the final product is also 25, so it is 50 kg. Hence, the feed that entered the dryer is 50 kg, and the water removed is equal to 25 kg. I think everyone got the question, and I think no doubt is there. So we can move on to the next question. So the next question is, a salt-free liquid product flowing at 100 kg per hour is salted by mixing salt solution of 25% to make the product 2% salted. determine the flow rate of the salt solution and the product flow rate after the addition of the salt. So, in the same way, let us start with the diagram. Let this be the mixer. Salt solution is entering, which has 25% concentration, but we don't know its flow rate. So let it be S. This is the feed that is entering at 100 kg per hour, and it is said that it is a salt-free liquid product. So the salt concentration here is 0, and the product has 2%, and the product has 2% salt concentration. Okay, so it is 2%, and we don't know the product flow rate. We need to find that. So let it be P, kg per hour. So first we'll do the total mass balance as usual. It will be 100 total inflow is equal to total outflow, and then the component balance, because we know all the concentration of the salt solution. So first one will be 0 into 100 plus S into 0.25 is equal to 0.02 into P. So from this equation we can write it as S is equal to 0.02 by 0.25 P. So S is equal to 0.08 P. Now, this is the equation 1 and this is the equation number 2. Putting the value on the equation number 2, putting the value of equation number 2 in equation number 1, 100 plus S is 0.08 P is equal to P. So 100 is equal to 0.92 P. So P is equal to 108.7. Okay. So the product is 108.7 kg per hour. This is the product flow rate, and the solution flow rate can be calculated from the first equation itself, that is 100 plus S is equal to P. S is equal to 108.7 minus 100 is equal to 8.7 kg per hour. So we can conclude that the product flow rate is equal to 108.7 kg per hour, and the salt solution flow rate is equal to 8.7 kg per hour. Thank you for being a patient listener. I hope you found this video useful. This was my first time using the digital whiteboard. So if you found this video useful, do hit the like button. It will surely motivate me for making more videos. Give your suggestions in the comment section and don't forget to share and subscribe to my channel. Thank you.